Hi everybody, welcome to Trigonometry in our first lesson, section 1.1. I just wanted to talk a little bit about it. The first thing that I would really love you to do is, if you haven't read section 1.1, then please go back and read 1.1. I know some of it's really technical with some of the terminology, but it will do you such good if you can first read it and then watch the lecture and in upcoming lectures as well, and then you can complete the assignment. So what is trigonometry? Well, it's the study of relations between the sides and angles of triangles. So the first chapter that we will start with, chapter 1, is right triangle trigonometry. And before we get into right triangle trigonometry, we need to talk about some definitions of angles. So you can see here, this is directly from the book. We have an acute angle. It's acute if it's between 0 and 90 degrees. And then we also have a right angle, which I know that you guys have probably seen this, has to be 90 degrees. An angle is obtuse, if you hear me ever say that, if it's between 90 and 180 degrees. And an angle is a straight angle if it equals 180 degrees. This is a picture of a straight angle, just a straight line. An obtuse angle, it opens and it's greater than 90 degrees. Here we have a right angle here that's exactly 90 degrees, and that little sign right here indicates that that's 90 degrees, and an acute angle that's between 0 and 90 degrees. These definitions we will be using throughout this class. Complementary angles, you may have seen that before. Their sum equals 90 degrees. So basically, angle A plus angle B equals 90 degrees. That indicates that they are complementary. So if I give you an example, suppose that we'll just say if angle A is 47 degrees and angle A and angle B are complementary, find angle B. So how would you find angle B? Well, you can say that 47 plus angle B equals 90 degrees. This is actually just a linear kind of equation. We're going to subtract 47 from both sides, and that will show that angle B is equal to, what is that? That's 43 degrees, if I did my math correctly. We also have two angles between 0 and 180 degrees are supplementary if their sum equals 180 degrees. Once again, there's this concept that angle A plus angle B equals 180 degrees. And two angles between 0 degrees and 360 degrees are conjugate or exemplementary if their sum equals 360 degrees. So basically, that's this diagram right here. So if angle A, for instance, was equal to, we could just say 60 degrees. Basically, if we start here, and this is where we will start in this class, we go all the way around, that adds up to 360 degrees, right? So I chose a nice number. If angle A is 60 degrees, then what can we say about angle B? Well, angle B would equal 300 degrees. And so angle A and B are conjugate. Because their sum, 60 degrees plus 360 degrees, 300 degrees equals 360 degrees. Your book has a nice diagram of the Greek alphabet, which we will be using some of these Greek letters. It's all Greek to me, right? So just get kind of comfortable with this. I'd be okay if you ever had this on an exam if you got confused. And I'm always pretty clear with what is what and defining that so you don't have to memorize. But probably the most common that we'll use in here, theta right here, this little, and I usually just draw kind of an oval with a line through it. And we'll also use pi a lot. So here's lowercase pi in the Greek alphabet. Okay. So the sum of angles of a triangle equals 180 degrees. I think that's something that most of us have learned somewhere in our math career, but that is very important and we will be using that in this assignment as well that you'll be doing. Isosceles triangle, if you remember, is a triangle, and I'm going to use this delta. This is the capital D for delta. It's just a triangle sometimes to denote a triangle. So it is a triangle with two sides of equal length. So also, if I draw some random arbitrary triangle and I put a little mark here and here, that just means that the sides are equal. Another interesting thing about an isosceles triangle, it also means that the angles are also equal or congruent, okay? And we're going to use that in a theorem in the next example. The last thing, a right triangle, is one angle is right, and thus the other two angles add to 90 degrees, or also means that they are complementary. So we'll do some examples shortly with those. So I always try to do some examples for you that are very similar to your assigned exercises, and I take them right from the section. So 1.1, number 2, I'd like to show you. It says, find the numeric value for the triangle ABC. So notice they don't actually even give you a triangle ABC. So if you're ever stuck and you don't know what the triangle ABC is, we'll draw it. So what that means is, here's a triangle and it goes in order. You could put the A here. It doesn't matter where, but then B has to go next to A and then C. So these are your three angles. So what I would also do, and I'm going to get a different colors, I would put in what you know. So I know that angle A is 110 degrees. So I'm a big fan of pictures and diagrams. And angle B is 31 degrees. So we'll call this angle 31 degrees. Well, we know that the sum of the angles in a triangle adds up to 180 degrees. So here we go, 110, whoops, 110 degrees plus 31 degrees plus angle C is equal to 180. And you don't need the degree symbol either. So 110 plus 31 is 141, I believe, plus angle C equals 180. And basically we want to subtract 141 over here. Angle C equals, what would that be, 39 degrees. Now, do you have to set up an equation like this, or can you just subtract 110 degrees and 31 degrees from 180 degrees? The answer is, as long as you show your work and explain whatever it is that you're doing, I'm okay with you arriving at an answer in a slightly different way. I just need to show this, and things do get harder where you do need to kind of set up an equation, and it's also a good algebra review for you. So angle C is 39 degrees. Next problem, number 4. Find A, B, and C if we know that angle A is equal to beta, so this is another Greek symbol, and B equals C equals 4 beta. So what we're going to do, and you guys can see the picture from before, the visual, so what I'm going to say is I'm going to add these up. So I'm going to say A, I know that A plus B plus C, and I should put a little angle symbol, angle A plus B plus C is equal to 180 degrees. So what I'm going to do is I'm going to substitute all of these angles in for terms of beta. So angle A is equal to beta plus angle B is equal to 4 beta plus angle C is also equal to 4 beta. So you're seeing some algebra here. So it's just like x plus 4x plus 4x, that's 9x. And I know that this is equal to 180. So what I'm going to do is I'm going to combine like terms. These are all like terms on this side. So that gives me 8x, 9, it's not x, it's beta. So 9 beta equals 180 degrees. And then what you can do is divide both sides by 9. So that tells me that beta is equal to 20, because 9 goes into 18 2 times and 9 goes into 0 0 times, so 20. But that doesn't tell me the measure of each of the angles. We're supposed to find angle A, B, and C. So that does give me angle A. So we can say that angle A, sorry, I'm running out of room here, is equal to 20 degrees. And then angle B is 4 times beta, so that's 80 degrees. And please include the degrees. And angle C is also equal to angle B, so it's also 80 degrees. One way also to check your answer is to make sure that all of these add up to, wait for it, what do you guys think? It should be 180 degrees, right? So 80 and 80, that's 160 plus 20, that's 180 degrees because these are all the angles in a triangle. For the next set, we're going to deal with 90-degree triangles or right triangles. And they give us the triangle ABC. C is the right angle. So when you're drawing your picture, you could say A, B, and C. That means that this angle is 90 degrees, and A and B add up to 90 degrees as well. They're complementary. So they say to find angle A and B if A is equal to alpha and B is equal to 2 alpha. So all we're going to do is we're going to say angle A plus angle B equals 90 degrees. We know this, so then we can say that alpha plus 2 alpha equals 90 degrees. And so alpha plus 2 alpha is 3 alpha. That equals 90 degrees. Divide both sides by 3. Alpha is equal to 30. But that doesn't tell us A and B, so we say angle A equals alpha, which is equal to 30 degrees, and angle B equals 2 alpha, which is equal to 60 degrees. Make sure that 30 plus 60 equal 90 degrees, and they do. So we found the correct answer. I just wanted to give you a hint for your assigned problem number 7. Number 7, it's a similar setup, but when you deal with number 7, you're going to be dealing with a quadratic. Okay? And when you solve a quadratic, I'll give you. So, for instance, if you have a quadratic such as x squared plus x equals 90, something like this, hint, hint. You need to get it into standard form, so we're going to do that right here. So x squared plus x minus 90 equals 0. And you can use the quadratic formula, identifying a equals 1. It's the coefficient of the quadratic term. B is the coefficient of the linear term, which is this, and C is the constant, which is negative 90. So you could plug it into the quadratic formula if you need a little review. I would just Google quadratic formula, Khan Academy maybe, and solving quadratic equations. That's a great review and worth doing if you're unfamiliar. But you can actually factor this. So we're going to factor that right now. Two things that multiply to negative 90 and add to positive 1, because that's the coefficient up front. So I'm thinking what's coming to mind, positive 10 and negative or minus 9. 10 times negative 9 is negative 90, and so on. So setting each of these factors equal to 0 using the zero product property, and that's something that you learned in Algebra 2. That implies that x is equal to, in this case, negative 10, or x is equal to 9. So that's your big hint for number 7. Okay, another important theorem that we will be using a lot this semester is the Pythagorean theorem. So if a right triangle, so I'm going to draw my little right triangle, and here's my right angle, has a hypotenuse of length C and sides A and B, then the Pythagorean theorem says that a squared plus b squared equals c squared. I think it's better to think about that idea, and it explains it in the theorem up here, that the square of the length of the hypotenuse of a right triangle is equal to the sum of the squares of the lengths of its legs. So a leg is something that's touching the right angle. That's how I see it. So another way that I like to teach the Pythagorean theorem, so you don't get confused on what, is that you have one leg squared plus another leg squared. And we could change these by saying that's the first leg, that's the second leg squared. And that's equal to the hypotenuse squared. And so the angle or the side that's opposite the right angle is always the hypotenuse. So get comfortable with that terminology. So I thought I would do one example from your book to show you how to apply this. And there's also a couple of examples in the section if you can read through it. So when the end of a rope is attached to the top of a pole 100 feet high, so I'm going to draw the picture. Here's my pole, and they do say you may assume that the pole is perpendicular to the ground. That's really convenient. So here's the ground right here. Perpendicular means that the pole and the ground form a right angle. So we know that the rope is 150 feet long, and we know that the pole is 100 feet high. So what I'm going to do is I'm going to take a rope and I'm going to stretch it out, and I know that this rope is 150 feet long. And so they want us to find this distance right here, and we can just call it A. And that's the maximum distance along the ground from the base of the pole to where the other ends can be attached. So stretching out this rope as long as we can. So what you do is you have to identify your legs. A is a leg and 100 is the other leg. So I write out using the Pythagorean theorem, a squared plus 100 squared equals 150 squared. So now we have to solve this problem. Okay, so we're going to expand this. A squared plus 100 squared, well, that's 100 times 100, so you just add the zeros, so that ends up being 10,000 equals. I wanted to show you guys, to use this opportunity to show you this really cool program. It's called Wabbit Emu. Right here it says it, Wabbit Emu. So what you can do with Wabbit Emu is you can download this app, and it works on Droids, and it also just works on your computer, and it looks like a graphing calculator, so you can actually graph things and you can use the calculator. So it's very handy if you don't have a graphing calculator. This is a good place to start. So go to Wabbit and see if you can get the app. And so what I'm going to do is I'm going to figure out what 150 squared is. So I do 150. Look at how cool this is. That's the square button. Enter. So that's 22,500. I'm going to subtract 10,000 from that. That is that. I'm going to take the square root of 12,500. I didn't actually show you what's going on here. Let's finish over here on the side. So 22,500 here, and then we're going to subtract 10,000 from both sides, and that's what I'm doing here to solve this, and I get a squared equals 12,500. Don't forget the square. If you take the square root of both sides, so that's what I was doing on the calculator, a is approximately equal to, and we can finish that up with the calculator. Drum roll please. Enter 111.8. And what are our units? Oh, feet. So the question, go back to the question, it's asking what is the maximum distance along the ground from the base of the pole to where the other end can be attached? So we can say then that the maximum distance is 111.8 feet. It's mentioned in your book, and we will be using similar triangles very soon, so I just wanted to point it out. So look on page 4, but also I just drew a little diagram. Suppose these sides A, B, and C. Well, a triangle that's similar to that is if I take a scalar, which would be half, or you could double all of these sides, half of A, half of B, half of C. The other interesting thing about similar triangles is their corresponding angles are always congruent. So this angle will be congruent to this angle is congruent to this angle. I just do different symbols to denote that there's the same, and I'm going to just call this a right angle. So that's just something interesting to think about. The ratios are all equal, so I could compare the smaller side, 1/2 A is to A, as 1/2 B is to B, as 1/2 C is to C. And if you see, I can cancel those out. That's 1/2 equals 1/2 equals 1/2. So just some things when we get into special triangles I wanted to mention. The last thing I want to talk about is Thales' theorem, and I just thought that the proof was pretty interesting, and it kind of it ties into everything that we've been talking about. So the proof of Thales' theorem, and the idea is that if you construct, basically this is the diameter of a circle, and what Thales' theorem says that um, the angle ACB, which is this angle right here, ends up being a right angle, so we could actually draw. So that's 90 degrees. Okay, the proof goes something like this, where they basically say, okay, draw a radius from O to C. So this is a radius, and if you recall, a radius is equal. It's the point from the center to the outside of the circle. So this is these are equal sides, and so are these. This is a triangle, an isosceles triangle. So what we have here with the isosceles triangle is that these angles are equal, and they call them alpha. And this angle, beta, is equal to this because this is another isosceles triangle. So notice that the big triangle, and I'll just draw it out so it's easier to see, has this angle alpha, and then this angle is alpha plus beta, and this angle is beta. So we know that a triangle adds up to 180 degrees, so if we add the alpha plus beta from this angle and this angle plus another beta, that's going to equal 180 degrees. So what do we have? I have 2 alpha plus 2 beta equals 180 degrees. And notice that there's a 2 in common with everything, so if we divide everything by 2, so divide this by 2, divide this by 2, and divide this by 2, we have alpha plus beta equals 90 degrees, and that's what we were trying to show, that angle C is equal to 90 degrees, because that is alpha plus beta. All right, that concludes the lesson. Please be sure to contact me. This is a work in progress, this online class. I'm going to do future lessons on CCC Confer, and so they will be live, and I would love as many of you to watch the live lesson and give me your feedback as possible. You can let me know on availability, best availability for you, but I'd like to meet with each of you individually this week. So please be sure to set up a time. Come see me in my office at Buckeye 5. If you need any help whatsoever with any of the technology, I'd be happy to help you. And remember that the ITC is open every day this week until 12:30, and that's in the library. So don't be afraid to ask me any questions that you might have. And be sure to upload your assignment, take your photos of your homework, upload it to the assignment portion in week 1 by Thursday at 11:59 p.m. Okay, bye everybody.